Hello everyone. What is behind me? A very pleasant weather or very pleasant climate? Tell me. Yes, definitely you will say a very pleasant weather. You think of a trip, you always think of going to Simla, Kulu, Manali or Mahabaleshwar. Why? Those areas have certain climate. You watch news. What is the last part of the news? When last part of the news comes, a weather prediction, you change the channel. Or if meteorology department or weather department announces that today is going to be very rainy outside, you're sure that today is not going to rain. You always make a fun of meteorology or weather department. If they say today is very clear, you will come out with an umbrella or raincoat. But weather, studying weather is a science. It is not just a prediction looking at sky. Definitely there is a science. We are studying this using satellite images nowadays, and we can precisely predict many things. If cyclone is coming now, recently cyclone Nisarga hits with very high speed winds, 150 to 200 kilometer per hour. This is when landfall happens or cyclone hits the shore. Similar kind of thing you must have seen. They are named as tornadoes. Cyclones or tropical cyclones happens only over the ocean and they hit the ground. But tornadoes can happen everywhere, either on ocean or on land. We study all these aspects in meteorology or weather. So what is weather? Weather describes the state of the atmosphere or any particular time. Weather can be described in terms of temperature, precipitation, snow, rain, wind speed and direction, visibility and cloud amounts. Whereas climate describes the average weather of particular part of the world at different times of the year. Climate is the average weather usually taken over a 30-year time period for a particular region and time period. Climate is not the same as weather, but rather it is the average pattern of weather for a particular region. Weather describes the short-term state of the atmosphere. Now, this typically a weather station. Weather station makes continuous measurement of different aspects of the weather. You will be making two things in today's session, that is wind and anemometer, to find direction of the wind and velocity of the wind. But normally weather station use standard instruments so that their readings can be compared. What you are making is just to understand various parameters, how to observe them and how weather scientists are taking readings. The most important factor is wind on the earth. What causes the wind? It is because of the heat we are getting from the sun. One part of the land or ocean gets heated up with the sunlight and air becomes warmer and goes up, which creates the lower pressure on that region. Whereas on the other side, you have cool weather, or that part of the surface is cooler, which have high pressure area. So air always flows from high pressure to low pressure, which causes the wind. And the very important factor, that wind direction and strength of the wind both are measured. Now all we know that we get rain with the monsoons, and monsoon hits first the southern part of the India, that is Kerala, and move further. So when you study winds, we need from which direction they are coming and what speed they're traveling. So basically we use wind vane to measure the direction and anemometer to record the strength. If you see, this is the Beaufort scale. So if wind speed is normal, that is 1 to 3 miles per hour, it is very calm atmosphere, calm weather, and as you see the wind speed is increasing, it turns into the cyclone or tornadoes, and your house, shelters, trees can fly. So it is very important nowadays to forecast the weather. In earlier years, we used to forecast the weather looking at the sky from the ground. So definitely there was some loopholes or lack of information in predicting the weather. But in some previous years, we are continuously monitoring every moment of the winds from the space. Yes, definitely using weather satellites. India uses Kalpana Metsat to keep eye on clouds and winds. So modern forecasts use computers to simulate the likely weather based on the careful observations from hundreds of weather stations around the world. And definitely satellite images and radar give better picture of the weather over a wide area. So scientists can predict that, for example, cyclone is formed over the ocean and in how many days it will hit the ground. So they can intimate the local people to move away from that region so that we can save lives. So forecasting is very much important factor nowadays. We can take images from satellite and those images are scanned and analyzed to predict whether it is going to rain or drought or cyclones. We use different methods when you have to predict something. And also a rainfall. Rainfall is also important thing. You must have heard about that meteorology department announces that this year we will have 96% of the rain, average rainfall. So it is very good science to study. Definitely you have to do a lot of statistics. You have to scan a lot of statistical data to predict these things. Now coming back to our kit, where you must have seen the image of tornado earlier as well. Tornadoes go by many names like twisters, whirlwinds and more. Tornadoes tend to form with severe thunderstorms when the air is unstable. Two different types of air collide with each other. One is cold and other is warm and holding moisture. The cold air remains near ground and hot air is pushed upward. The water droplets of warm air form clouds. Ground becomes hot due to the sun and cold air starts becoming hot. It gets trapped near ground under the layer of incoming cold air and if finally breaks through, forming a fountain up through the cold air and into the sky. So tornadoes last for shorter period, whereas cyclone last for weeks and they spread over hundreds of kilometers. Whereas tornadoes are small and they last for few minutes and they are widespread for 1 to 2 kilometers. Another small tornadoes are formed when dust devils are formed. You must have seen this while you are playing on football or any cricket ground in summers mainly. So these dust devils usually are small and it lasts only for few minutes. When hot air near ground starts rising, it gets a kind of spin. This leads to formation of a dust devil. Now we will make few kits to study wind speed and anemometer. So let us begin with the making of the kit and perform few experiments in this kit. Once you open this, you will find a lot of bowls, these plastic riders, a tornado tube, plaster of Paris, a thermocol sheet, few pins, toothpicks, color pouch, a corrugated sheet, and two Magdeburg hemisphere. Now our first job is to make plaster of Paris in this bowl. We have to make paste of plaster of Paris. I'm just cutting this pouch. Take plaster of Paris, in both the bowls. We have to make thick paste of POP. Make sure that you are not pouring more water into it. Pour water so slowly in both the bowls. Make sure you are not pouring more water. Using stick in the kit, just to stir it. Now, as you can see, this is not a thick paste. You have to make thick paste of it. So additional water you can throw, and now you have to add more plaster of Paris into this to make it thick paste. This is again not thick. This should be thick as your Colgate paste. So instead of adding water first, go on adding water slowly, step by step. Such we have to make two bowls. Once your paste is ready, we have to keep it for drying in sunlight. If paste is not thick, it will take more time for drying. We have few straws in the kit. If you see them carefully, there are two straws are with this both side tape. So this is for fixing in this rider. So insert this inside like this, and we have to insert this rider inside this and make sure that it is standing straight. It should not be tilted. So once this is ready, we will keep it aside for drying like this. So keep it away for drying in sunlight at least for half an hour, and then again we will use this two base for our two experiments. Draw such arrow lines on this corrugated sheet, and we have to cut this using scissor. So this will be our arrow for wind vane, and we'll cut this tail as well. These two parts are of no use, so keep them aside. Basically we need these two things. This is arrow of wind vane and this is tail or stabilizer of the wind vane. Now we have to connect these two using this straw. So first of all, open this. You will find these board pins. You have to handle these board pins very carefully. Insert this board pin. So this and then insert this board pin onto this. But one is not sufficient, because when you put one, it will have this moment. So we have to put another board pin into the straw. Make sure that it is horizontal. So before you press, make sure it is horizontal, perfectly lined. And after that, we need to fix this onto this tail like this. So here as well we need to fix this using these two board pins. So when you are inserting this board pin, make sure that this plane, otherwise your arrow will be not in one plane. Press it, and also make sure that you are putting second pin on the same plane, and then against any hard surface you have to first press them. Make sure that you are not inserting it into your finger, and then finally insert them like this. So this is your arrow. You have to find its center of mass. So hold it on a position where it is, so this pin is coming out, so you have to insert it firmly, and you may put any additional tape from other side. Now I'm sitting in windy condition outside, so a lot of wind is there which is disturbing me. So first of all, you have to find its center of mass. So hold this on your finger and find out a point or a position where this is steady. Now you can also see that a lot of wind is disturbing me. So I think this is my point. So hold on this point, and here we need to prick. Now this is the orientation. We need to insert this toothpick from this orientation, so this will stand like this. So I am inserting it from this position. Make sure that it is going straight like this. After making this arrow, we have to make some assembly for anemometer. So we have these 4 balls. Take first red and blue color bowl. We have to join these 2 balls using the straw, but not in this orientation. So I will tell you that how to join them. First of all, take a straw, insert this pin through the straw like this, and then put it on a center and press it with your finger. You can use handkerchief to press this. Now, as you know, this one is not sufficient, so we have to insert one more pin here like this. After this, we have to attach this another bowl on another side, but it not in this orientation, but this bowl will come exactly 180-degree opposite to first one. So I'm just rotating it, and here you have to first mark your point like this. Make sure that you are not connecting in this orientation. Face of this bowl and this bowl should be exactly 180-degree away from each other, facing back to back. So mark this point first, and before you press, again check the plane orientation like this. So they are exactly opposite of each other, and then press the second pin like this. So they are facing away from each other. Similarly, the same process you have to do with another two bowls. So take one more straw, insert the pin at the end, put it at the center and press the pin. Take one more pin, mark a point, making them exactly opposite. Again, we have to find center of mass for both these assemblies. So hold it on your finger and find the center of mass, the point. So this point is here. So in this position you have to prick your, see, if this is the point, this hole should be in this orientation. So mark that point carefully and take it straight from this. So if you see it clearly, this is the orientation it should have. So when you hold it in this way, this will move like this. So make sure that it is in this position. Take out the toothpick, find the center of mass for another pair, hold that point, repeat the procedure. Like this. And now after this you will put these two in this way. But now first of all I am showing you what is wrong. So you can see both these faces are facing each other. This is wrong. So remove this and insert it in such a way that it will be like this. So when it will move with this blue color, now you must have understood why we have used this one blue color bowl, because when it will take turn, you can count the number of rotations. As you can see, blue bowl or blue color separately, if all four are red, you cannot count the number of rotations. So for that reference point of view, we have taken this blue, and make sure that this should be always plus. This should not become X like this. So make it permanent plus. You can put one additional drop of Fevikwik in between these two straws, so they will remain in plus position. Now still our both this is for wind vane and this is for anemometer, both are ready, but you have to make sure that your POP is completely settled or dried, then only you can mount these two anemometer and wind vane on that base. Meanwhile, you can do one additional work. This piece is given to us. We have to mark or cut 4 pieces out of it like this. So take any cutter, handle it very carefully and keep these 4 pieces ready for direction. So you have to write direction on both the sides. So this is N. From another side also you have to write N. Similarly, south, south, east, east and west. We will fix this on that base when that base is completely dried out and ready. Meanwhile, there are 2 more activities. This is a tornado tube. We will give one link to make how tornadoes work. This is color. So you need 2 Mirinda or Sprite bottles to make this tornado work. And this is Magdeburg hemisphere. Basically, this is the famous experiment done in a village of Germany. All we are living on the surface of the earth and we have lot of atmospheric pressure on our head, or every one of us, and this pressure is not only from upside, but this atmospheric pressure is equal from all the sides. So take this 2 Magdeburg hemisphere close to each other. Now what is there inside this Magdeburg hemisphere? Air is there. What is outside of this Magdeburg hemisphere? Air is there. Just to tell you that how much of air all we have above our head. So if you stretch your 2 arms above your head, this we will as air column. This air column goes to some hundreds of kilometers in the sky, and that much of air particles putting pressure on your head at any given time. So what is the mass of that air column? It is almost equal to the mass of one big elephant. Yes, all of us, we are carrying one elephant on our head. So why don't you feel that pressure? Because our body exerts the same amount of pressure from inside. So what is this experiment all about? That air exert or atmosphere exert pressure. So take these close to each other and press them. So air will come out and vacuum will be created inside this thing. Now here atmospheric pressure is pulling or pushing this Magdeburg hemisphere, and this atmospheric pressure is pushing this Magdeburg hemisphere from this side. So now you have to separate them using your 2 fingers. It is as good as separating 2 elephants from one another. You can feel this pressure. It is not that much of easy to separate these 2 things because there is a vacuum in between these 2 Magdeburg hemisphere. But if you allow air to go inside, you can separate them easily. With the same thing, you can lift heavier objects. So I am just putting it here, and you can feel the pressure. You cannot lift it. You can try different experiments for Magdeburg hemisphere. That link also we will give at the end of this video. So our wind vane is ready. Just to tell you, make one cross of toothpicks like this and put east, west, north and south labels and place this matching with the actual direction at your place. So if your south is on your left hand, match it with on the ground, so that this arrow will give you the exact direction of from which direction wind is coming. This is stabilizer. This will be always in the opposite direction of the wind from which side wind is coming. So, if this is the position of arrow, it means that wind is coming from this side to this side. If you place it somewhere in the window or in gallery, arrow will move round and round because wind is moving in circular motion here. So, this is the function of wind vane, to find the direction of the wind from which direction it is coming. And now our second model, wind vane anemometer. So, here you can see, you can start counting the number of rotations, taking blue as a reference bow, and count how many turns it has taken in 1 minute. We will see the formula to find the velocity of wind using anemometer. Here you have to place this on a bead. Just I will show you by taking it out. You have to cut this wooden stick, insert this bead, and then you will place it into the straw, so that bead will not create much friction, and wind vane and anemometer can move smoothly onto the straw. Let us see how to find velocity of wind. If you see this 4 bowls carefully, diameter is actually your length of straw. So, around this diameter you have to find circumference of this circle. Now, number 1, you have to place the anemometer on terrace, determine the number of revolutions per minute. So, you will obviously see the blue bowl and count the number of turns. Note down this figure you have calculated in 1 minute. Divide this figure by 60 to get revolutions per second. Remember, this value will be your T. Second, measure the diameter in centimeter. I repeat, the diameter of this circle is actually length of the straw. Calculate the circumference of circle in meter by the formula C is equal to 3.14 into D divided by 100. Why you are dividing by 100? Because you need to convert this centimeter into the meter. So, this will be your second value C. And finally, you have to do some mathematics to find out the velocity of wind. Velocity of wind is equal to C into T, and this answer will be in meter per second. So, whatever value you find, that velocity of wind will be in meter per second. Now, today you have learned about how to record the observations about wind vane and anemometer. You will perform the activity of tornado using 2 bottles of Mirinda or Sprite.